Testing mic. Yeah, I am audible. Okay, so today is 27th of February and this is going to be attempt 3 at Hard75. I'm listening to myself, so I'm just going to mute Twitch and then we'll get started. So this is my third attempt trying to do this. First attempt went 3 days, second attempt went 2 days. The second attempt that I had started tracking. This is technically my third attempt starting today. I'll be documenting everything that I do. This is the easiest, maintaining food related thing. Goal 1 is the easiest, workout becomes a bit harder. What is the hardest part of this is actually posting, like documenting and posting on social media and building something consistently. These are the things I'll be focusing on. I'll change it to note. So there are 7 targets. One is maintaining a solid diet, 2 workouts a day, taking a progress picture and daily veins, drinking water. These are the 4 fitness related targets, pretty straightforward to accomplish. The last 3, learning something, building something in data science and Web3, and documenting it on social media. These are going to be a lot harder because the perfectionist inside of me takes over and I just don't want to ship anything or post anything out there that's not as good as I want. That is something I want to change, and this journey is an attempt to do that. But shipping out something, writing out something is more important than it being absolutely perfect. The another key thing is accountability. I've been working from home for a long time and trying to build something of my own, so I'm accountable and responsible to myself and my co-founder. Sometimes, like when I'm tired, I don't want to do things, I end up procrastinating. Like I read things, but it's like it's a false justification that I give myself that I am reading and researching a lot of things, while the primary objective should be building and shipping something out and putting something out there, like getting hands-on practical experience. So this is another attempt to change that. Yeah, at the end of it, like these are objectives, the ultimate higher level goals I should put here, and I should rename this to objective. These are more like KPIs. Some major problem. Second is accountability, transparency. There have been times where I felt like I've worked a lot the whole day, but when I look back on it, the productive outcome has been very low. Documenting everything about my life and streaming it and putting it out there is helping me and forcing me to look at things and look at the mistakes that I'm making. So a lot more accountable to myself as well as to anyone watching this. So I hope you also get something positive out of this. Join me on this journey and let's get started. I'll add a couple more goals as I think more about it. And I think these are the primary two things that are there right now. Okay, so currently the time is 11:23 a.m. First session of the day. I'll probably work for about an hour, then I'll go to the gym, and the first session that I want to keep is something around learning. So let's learning as well as creating a pathway for experienced Web2 developers to transition into Web3. I have a couple of friends who have been asking me, and I've been working closely with them, and they also want to explore as to what exactly the world of blockchain and Web3 is. So in my previous videos and a couple of posts, I've talked about the requirements and the primary mental model shift coming from Web2 that is required when you enter Web3. Working on that. Yeah, something like TypeScript, a lot more front-end heavy, CRUD operations through direct DB interactions, different ecosystems, good experience in Next.js, and then the different verticals that are there. So what we have done so far is the absolute basics, how does asymmetric cryptography work, the concept of a wallet, the transactions, its structures and different fields. In the blockchain nodes, we'll come back to the blockchain nodes and try to run a proper node and as well as look into Geth client for Ethereum. Then we did a bit of transactions and smart contract related basics from Mastering Ethereum book. And these are actually really helped me clarify a lot of the concept that I've been using, but I did not have as much of clarity over these fundamental things, such as a very basic thing was asked in one of the interviews, like message.sender versus transaction.origin, and I answered it, but I could not answer it as clearly as this crisp line here would have told. So yeah, I'm also picking up things and slowly building up from absolute basics. It has been a massive shift for me as well, working a lot into data science, AI, ML, and then using Python, Django, and transitioning into this. Technically, I've been a founder and as well as leading the tech for Purple Pay, but yeah, I've made mistakes, and this is again one of the processes of learning from those mistakes. So contract definition, how do you define a contract, the different syntax to write a function in a contract, error handling, events, security related challenges that are there. And finally today, let's do tokens properly in this 1 hour session. So what exactly are tokens? What are native tokens, ERC20 tokens, the EIPs related to them. We'll keep on building over this, but today I'll just do the 2-3 basic tokens and how they came to be, what was the requirement for them. Again, I'll be using Mastering Ethereum as the base. Let's quickly code up few tokens. its technical definition goes something like this. It's a blockchain based abstraction that can be owned that represents some sort of an asset, currency, access rights, and can be owned. So what are the different applications of tokens? These are the ones given in Mastering Ethereum. I'll explain all of these one by one. A close friend is getting married, so he is asking for some advice regarding his attire on WhatsApp. Yeah, sorry folks, coming back, let's quickly do a list of applications for tokens. Entity attestation and utility. So let's go through all this one by one and see how these applications are achieved for the token. Go over this. So for any currency to act as a currency, what do you require? Like you require the group or the people who are using it as a currency to accept it and trust in the value it represents. So in an abstract form, if you look at any fiat money also, let's say your US dollar or Indian rupee, ultimately every note that you have, it's some sort of a token. See, there is a serial number, there is an amount that it represents, and then there are ways to ascertain its authenticity. Through some sort of symbol, watermarking, whatever. And person A, person B, whoever is agreeing to use this, they have this particular physical note as a potential token. They give this and receive some sort of a service in return, let's say a coffee. So even hard currency or a note is also a token. Now consider a digital representation in some sort of a mapping. We have already seen the addresses. Let's say this is person A, this is person B. In a contract, you now have a mapping where A has 50 of, let's say, ether, B has 10 ether, or we can also use USDC as an example, better example being an ERC20 token. So in this arrangement, there are two things that are implicit. One, A and B have agreed to use USDC as a currency or a medium of exchange. And A and B trust this token. So now when A transfers, let's say 20 USDC to B, this gets updated to 30, this gets updated to 30. So instead of actually having like those physical currencies, you can have a digital representation of those currency with these two underlying assumptions, and that is how a token can be used as a currency. Now the second is the resource. So currently, like in physical or Web2 world, you work with bills or some sort of receipts. Let's say there is a warehouse. A part of it is reserved for vendor A. The other part is for party B. And they have a receipt for this much volume that they can use and so on. So again, it can be converted into a digital representation where there is a resource sharing environment. Let's say you have a CPU or a machine or a hard disk lying idle. You can share a part of that hard disk. And in return, you get paid a token. User can use this and pay you a particular token. This is again a very simplified version, but it combines the two concepts. One is any sort of sharing function can be converted into a set of tokens. Whenever you provide a service, you will get a token in return. So there are now two types of functions here. One is your proof of sharing a particular resource. This acts like your receipt from warehouse. And the second, when someone uses your particular shared storage, so they pay you a fee. These are the two types of things that are combined. This is combining one where some sort of a payment is being made because a token is being considered as a currency. Second is when you are sharing your hard disk or any particular resource, you are getting a proof that hey, I have shared this. Let's move on to the third one, asset. Asset is again pretty straightforward. The simplest example is your gold. You have, let's say, gold coins. Each gold coin, let's say, is worth $1,000 US. So now you have asset worth $2,000 US, but you have to carry this physically and secure this physically. Now imagine its digital representation. So in India, there is a scheme that is called your RBI's sovereign. RBI is India's central bank, sovereign gold bond. So what it does is RBI is the one that has the custody of the gold. Then it notarizes it and converts it into some sort of a bond. And the user can buy this particular bond. So user does not have to maintain custody of the physical gold itself, which can be insecure. They just need to maintain this particular asset, the digital representation of it. Now imagine this completely decentralized, and this is why Bitcoin is called your digital gold. There are a bunch of there's a network that is mining it, and you get your Bitcoin. And you as the user, you can buy and keep the Bitcoin. So the network is kind of operating like the entity generating the gold and its virtual representation, and the user can directly with the actual output or the representation of it, which is your Bitcoin. The fourth use is access. It's pretty straightforward. Like when you have taken a MRT or tube or metro, it's like whenever you are entering the train, you need to, from the counter, pay some money, get a token for your journey. Then you go to the turnstile, when you are entering, you have to put the token into the turnstile. So this opens and you as a user can board the train. So this is a token that allows you for access. Another example would be you having a pass for, let's say, a Taylor Swift concert. That pass acts as your access token. Now in the world of Web3, what you can do is have these exclusive, let's say, groups or membership groups, and you can have something called a NFT, which is essentially just a token, and you can launch, let's say, 100 tokens for this. So 100 different users can buy these, and then let's say there is a some sort of a group, online group. Only if you have this access token are you allowed to enter and access contents of this group. Fifth comes in as equity. Again, you have a company in Web2 world. Company has a bunch of shares. Similarly, you can have a DAO, which is a decentralized autonomous organization, and you can own its tokens and have your say. Next thing that comes in is voting. Similarly, you have a Web2 where you have a ballot that you can cast into a box. Here you can have some sort of a token, and then you can assign to a candidate. Now the multiple different use cases might also come together, such as your access plus voting plus equity comes together. Like you may have a certain amount of equity, let's say you need at least 0.5% of DAO equity plus a particular kind of voting token plus some sort of an access token to be able to vote on certain issues. Then comes in your collectible, one of the most widespread usage. Simplest example, Pokemon cards. These were physical assets at one point. Now you can create a virtual representation and own it. Another rapidly emerging area is your generative AI based collectibles, something like your Vision Cast NFTs on Warpcast. Next is your identity. Let's say you have a passport, voter ID. All of these can be converted into on-chain representations. For those of you who are more curious in this, look into ZK based DIDs, decentralized identifiers, and sovereign identity. Finally, attestation. This flows from identity as well, such as you have your marriage certificate. an on-chain representation can be made. And lastly, token being used as a utility. The best example is Ether. And gas. So you pay Ether to use gas, which is your computational unit. On Ethereum blockchain. I hope this makes the 10 use cases for a token clear. Now let's quickly move to the concept of fungibility and non-fungibility. I'll be back in 10 minutes. let's get into this quickly. A token that can be interchanged. I don't think it's too much of a difficult concept to understand. I'll quickly take the example of a currency. Let's say you have a $50 note. Its serial number is SN1. There is another with serial number SN5. This is also $50. If you interchange it, still have $50. These two are equivalent in all aspects. This is called a fungible token. So in our particular use case, when you're writing a ERC20 contract standard, which is the standard for a token, let's say USDC, inside this it has a mapping. This mapping is just like a Python dictionary. Let's say user A has 110 USDC, user B has 80 USDC, and this user A will be represented by their Ethereum address. User B is represented by time. Please, quick. So in this mapping, if you see, it's just written an aggregate amount. Now let's say user A wants to transfer 10 units to user B. This 110 becomes 100 and this 80 becomes 90. But this is an aggregate representation that is just put as a number. It's like a table with number against a particular user. Within this 100, there is no differentiation between like 1, 2, 99th unit of USDC that might be there. Okay. Hence, an ERC20 token is fungible. It just works on the aggregates. We're just writing a number against a particular user. This number is the user's balance as to how much they own total amount of USDC. Aggregate USDC owned by a user, maintained inside USDC's ERC20 contract. Now let's consider the other standard, which is your ERC721. This is non-fungible. Here the mapping has a deeper layer. 0x123A, user A is not directly connected to the balance. There is a layer in between. And then there comes in the balance, which is the amount, this is the aggregate amount owned. So the aggregate balance is not directly dependent on the overall address of the user. There is something called a token ID in between as well. So user A, let's say we have Pokemon cards 100 with their own different IDs. Let's say this is Pikachu. This is Pikachu's another card, Pikachu 2. So user A owns Pikachu 1 and there is only one Pikachu 1 that is available. Let's say user A owns Pikachu 2. In total there are, let's say, 10 Pikachu 1s and there are 40 Pikachu 2s. So user owns 1 of Pikachu 1 and user A owns 3 of Pikachu 2. Similarly for user B, they can own 3 of Pikachu 1 while own 10 of Pikachu 2. And all of these will be unique. These token IDs will be unique. Actually, what I did here by making multiple of a particular token ID, this partially overlaps with another different ERC standard. For ERC 721, I think each of these are going to be 1 and they are not going to be interchangeable. Like this will be Pikachu 3, this will be Pikachu 4, again will be 1. And these token IDs are not going to be interchangeable. If they have multiple of a particular token ID, they can be partially interchangeable. Which is where ERC 1155 comes into picture. Let me rephrase this. For non-fungible, token IDs will be unique. Two different tokens cannot be interchanged. This is a bit of clarity that I also got from this. Okay, moving on. there is one important concept that is called intrinsicality. It is when tokens represent some sort of a digital item which are intrinsic or inherent to the operation of blockchain itself. So here the blockchain consensus rules apply, and this is critical in establishing your ownership over the asset directly. Your private key to an address which owns the asset is equal to your asset. This will become clearer once you go through the consensus mechanisms for Ethereum and how Ether as a token required for consensus versus ERC20 token created artificially on the top of a blockchain, and how the assets owned by these two things differ. This applies very well for the native tokens of the blockchain. Okay, so let's quickly take a look at what exactly this means. It has its own token which incentivizes different nodes to come at consensus. Is critical for consensus, acts as an incentive mechanism, application of game theory. I'm not going too deep into this, but do read Bitcoin's white paper to understand this better. The second is ERC20. This is the network. On top of this network there is a ERC20 contract. This is written and put in by a company such as Circle. So in case of the native native token to Ethereum, you are the user, you have the private key which gives you a Ethereum address, and whatever is the balance, let's say 10 Ether, this lies directly with the node, and this is governed by the consensus rules. So for you to be able to lose this Ether, you either have to lose your private key or the entire network has to go down. Okay, So your ether that you are owning with your private key, this is lying directly within the blockchain itself. However, in this particular case, let's say you have the mapping where Circle has launched an ERC20 contract, and inside this contract there is a balances mapping. Within this balance you have the account 0x123 and you own, let's say, 100 USDC. If this is again not a more of a practical thing, it's more of a philosophical thing. Let's say if Circle decides to delete this contract, if this contract is deleted, you will lose all your USDC. If this contract is hacked, you might lose all your USDC. So whatever is happening here on the contract is not directly being controlled or governed by the blockchain nodes itself. It is governed by an external parties and their particular code that is on top of the chain. Let's say the government bans a particular USDC contract, you might lose. So this becomes an extrinsic risk. You are in a way trusting Circle to honor its USDC contract. Now, even with intrinsic tokens, some of these might happen. Let's say government tomorrow bans all blockchains and Ethereum. Then this entire network goes down. But even if one node operates, you will still be able to access your ether. Here, if Circle goes down, removes the contract, your entire thing is lost. And Circle going down or removing the contract or being banned by the government is an event that is outside the blockchain. Here, your native currency is governed by rules and consensus inside the blockchain. So this is called intrinsicality. I'll stop here for now. I'm going to the gym. I'll be back from gym at about 2 p.m. I will join you in about 1.5 hours. And then what we'll do, we will go through ERC20, ERC721. I'll also try to go through ERC1155. Then we'll use this properly in the raffle forecaster product we were building. See you in a bit.